Okay, so now we are doing not today but yesterday's daily code problem. 2246 longest path with different adjacent characters. Okay, so yeah, you have been given a tree. Okay, tree basically, connected undirected graph. That's what your tree is without any cycle, right? So this is not obviously binary tree. It can be it can have any number of childrens. Like in this case, this have three childrens or something like that, and rooted at node 0. So node 0 is always the root, consisting of n nodes labeled from 0 to n minus 1. That's why the n nodes labeled from 0 to n minus 1, represented by 0 index parent. Okay, so now this is basically the representation of tree. uh, there are multiple ways to represent a tree. Somebody can give you an edge vector, but no need of edge vector, right? It's more detailed in kind of a graph. And this let's they said only undirected tree without a cycle, which means that one node have exactly one parent, right? One parent can have multiple childrens, but one node will have exactly one parent. So for example, so this is the parent vector they are being given to you. So one has parent 0, 2 has also a parent 0, and 3 has parent 1, as you can see. 4 has also parent 1, and 5 has parent 2. So in this way you can create a graph just by looking this parent vector, and that's all about it. You have been given parent of I to create the graph or tree. Since the node is 0 and the parent is node 0 does not have any parent, so parent of 0 is equal to minus 1. And you are also given a string. Basically it's a character assigned to a node I. S of I is the character assigned to the node I. Now what you need to tell, you have to return the longest path in the tree such that no pair of adjacent nodes on a path have same character assigned on them. So basically, no pair of adjacent node should have same character. Like in this case, 0 and 2 are adjacent and have a character same AA. So this is not valid. Okay, this is not allowed. So in this graph, can you tell me, or this tree, can you tell me what is the longest path in a tree that have no adjacent node as the same character? So you can see ABC is such a path, 0, 1, 3. ABC is such a path that ABC is obviously different. ABA is also, good thing because adjacent nodes are not same. You just have to focus for adjacent node. It's not like, if A has occurred, A cannot occur again. So A can occur again, but A cannot, two A's cannot occur together. So that's about it. So yeah, in this case, answer is 3. In this case, answer is, what is answer is? Can you tell me? It's 3 again. CAB. This is also good. Yeah. So now, if I talk about directly about the approach of this problem, it is something similar to this you will find everywhere. That yeah, it's obviously similar to what your diameter kind of thing, because obviously you're returning the path. So every path question is kind of a similar to diameter kind of thing, because diameter is also the longest path in a tree. Diameter is also the longest path in a tree. There's no doubt about it, right? So he also wants from you that longest path in a tree. So is it the same as to return a diameter? So in this case, diameter would be, of length 4. But diameter will not say that this EAABB, which is a diameter like 52014, is a diameter, because it has maximum length of 4. But it will not say that A and A are adjacent, B and B are adjacent. That is not valid for us. So diameter with a condition. So diameter with a condition of different adjacent, yeah, different adjacent node character, different adjacent node character, something like that. So this only thing you need to implement. So complete code is just same as diameter. You just need to add one, one variation whether you are considering this to be, let's say, now how the code will proceed. You now after getting this idea that it is something very similar to this diameter kind of thing, how the code will proceed. First of all, you start at the root node A. I'm just taking this example. I cannot copy this, but I can draw this for you again over here. 0, 1, 2, and something like that. Okay, it's 2 1, not 1 2. It's 2 and 1. And then 2 has children like 5 only. 1 has children like 3 and 4 only, right? Now what I'll say ki I'm starting at zero node. Okay. After that I'll go to its children, which is two. Then so this is also post order. Okay, let's see, like we did recently a post order question in previous or the previous video, I think, or DER post order. So calculate for child before calculating for parent. Calculate for child before calculating for parent. So this is the post order condition. So before zero you will go to two, then you will go to five, and then first of all the answer for five would be zero. For 5 is equal to 0. Okay. So वो 0 will what this means is that 5 returned me something like, there is nothing below the 5 which is valid. Okay, so 0 length is valid below the 5. So now it will return 0 to, let's say, node 2. Node 2 will see, okay, he's returning me 0, that's fine, but is A or E different? Node 2 will say, yeah, A or E is different. So node 2 will say, okay, 1. What this 0 is, max length below, max valid length below this point, valid length below this node. So there is nothing below this node, that's why answer is 0. And similarly there is only one length valid, so the answer is 1 for this. Similarly answer for 1, what it would be? So answer for okay, 1 is not, basically parent of 2 is 0. So answer 0 would be coming from 2 and 1. So he'll be asking, 2 will be returning him because 2 has 1. Okay, so 2 will be returning him 1, and he can do plus 1 if this is valid, but this is not valid. Okay, AA. So what it will do, will it will say, okay, don't do plus 1, just keep 1 as it is? No, it will just break out and make it 0. So for 0 there is nothing coming from the left part. You cannot even take a single edge from the left part, even if this A and E are different, but this middle A, which is hampering the condition, so you cannot take a single thing. Okay, so that's all about it. Yeah, then the answer becomes 0 at this point. So if it was like the case that how can I tell it, so A is 0, A is 2, and currently E is this. So I'm saying that it's not happening over here. If there are one more, let's say something 9 is not there currently. So 0 has children called 9, and 9 has children called 2, and 0 also has children called 1. Okay, how to do this? 1. Basically I'm trying to show you that this 0 is over here. Let's say 9 and 2 becomes 0, and there is also some more nodes. Okay, I'm not showing the right part currently because I'm focusing on the left part. So on the left part there is another node, let's say 8, which is not there. It is having node character as B. So what I'm saying, this AA 92 is not good. Okay, A is good, 25 is good, 9 comma 2 is not good because both have same character. So answer for 9 will return, so 9, what 9 will return, 9 will return 0 from left hand side. Okay, there might be some of the nodes which is valid on the right hand side of 9. So for example, right hand side of 9 contains, let's say, 10, and B is the character, so that's fine for this 9. So A, B is fine. So 9 will return basically 1 to its parent, but yeah, the answer coming from the left hand side is 0 and the right hand side is 1, so that's why he'll return 1. But there was no right hand side, so that's why answer is still 0. But then you will say, ki, okay, the answer is 0, but no worries. Now uh, 8 has got 0 from 9 side, and BA is valid, so that's why answer for 8 will become currently equal to 1. And then you'll see for other children and see maximum of all them, just like how we do in the longest this how we do it in the diameter of a tree or longest path in a tree, something like that video that you should focus on, or something like that for question that you must focus on. But this is what I'm telling you, the basic logic for that diameter and longest path also comes from that those two cases. That for example, this is a tree, let me just draw without I'm just doing the longest path and diameter wala question, just for the sake of explaining it, because that's relevant for this problem. I'm drawing a big tree. Okay, this is all about my big tree, and let's say there is one node which is having a very good length. So this node is basically increasing very down. So this will give me the maximum path. I am creating this in such a way that this should give me the max path or the diameter. Okay, and then similarly on the right hand side also he is having very large number of nodes. So these dots are basically the nodes in a tree. So that's why. Can you tell me what is the diameter for this tree? I can see the diameter for this tree is 1, 2, 3, 4, 5, 6. How many lengths is up to here? I had drawn. Okay, let me reduce it. I think because dots have very small visibility. So 1, 2, 3, 4, 5. 5 from this side. 1, 2, 3, 4, 5. So diameter equal to 10. I just got from this. This going back till here. 5 edges. 1, 2, 3, 4, 5, and over here 1 2 3 4 5, 5 plus 5 10. uh, any other possibility? Yeah, 5 from this obviously, and then 6 from this, 7 from this, 8 from this, 9 from this, right? So 9 is the second diameter is 9. So basically this is what we are returning now. This node will say, okay, the maximum diameter below from me is 9, okay, that he has calculated by somehow. And then he has also said that what is the maximum just length down from me. So maximum length is just 5. You can take only one side if you are allowed to take only one side, because that's about it. Now if you take longest path, then you cannot include this into your path, because then the path will have only one bend, and one bend is coming like in this way. After this node you take in this root node, and after this root node you move backward and take in this node. So that's about the path. But now you are returning just one side of a path, so that other you can take parent element. So then you'll return 5, and then 6 for this, 7 for this, 8 for this, and 9 for this. These 9 will add. Okay, so now I'm writing the code for the diameter, and then we'll say how we have to modify it for. I think we should store this something like. If you have a idea about the diameter problem, then it would not be a difficulty for you. You will just look into this code, and this will be pretty good. So diameter also just have only one DFS function, and the DFS function will have one your starting vertex. I like to keep it like this way. And for even this, in this case, you don't need a visited. Why you don't need a visited? Because this parents are given in such a form, like it's moving only downward only. 0 is going to 1 and 2, 2 is going to 5, 5 is not coming back to 2, right? And we don't even need 5 coming back to 2. So that's about it. So you can have a visited, you cannot have a visited. But if you draw a graph like this for auto, not for auto, int I equal to start from 1, because starting from 0 doesn't make sense, because 0 has no parent, I plus plus. And basically graph I'm creating. So g of p of I, no, g of yeah, p of I, which means this is a parent dot push back, its child is I. So 0 has child equal to 1, which is the index where 0 is present. Okay? 0 is also present at second index, so 0 has child equal to 2. So yeah, this is a undirected and acyclic graph. So you can just yeah, in kind of a acyclic graph you can just ignore kind of visited thing. So for auto I in g of sv, you are going into the graph, and then you are saying you are okay, like how we do it in the emitter problem. We decide, or just like what I showed you, that you have, for this current node, you have to calculate a maximum length down from here. Not only just maximum length, two maximum length, because those two maximum length can be a candidate for a diameter. Like in this case 5 is the first maximum, and second maximum is also 5, so that's why the candidate for the diameter is 10. So you will say int x equal to 0, y equal to 0, and if it's not okay, so int z is equal to dfs of I. This can be my possible candidate only if, okay, now there comes a condition, a special condition, which you will implement. But before this, let's say key, if the normal if it was a normal diameter question, then you would just have said if your z is greater than x, then if your z is greater than maximum, so x is my x is my first maximum, ठीक है, first maximum, y is my second maximum. These things to note that I need two maximum. So x is my like biggest of all. Y is my second maximum. So z is equal to, or not z equal to, first convert your y is equal to your x. So y becomes that, x becomes z. Now x is also the maximum of all, y is second maximum, lesser than x. This you will do even if it is equal to, right? Even if it is equal to, because y is incrementing and x is also incrementing or keeping same, so that's why you have to do this. Else if, not else, but else if it should be greater than y. At least it should be greater than y. Not even equal to y will not work because that's already there. So it should be greater than y, then it can change up to y. And yeah, uh, x we have already checked that it is not greater than x. So that's about how I will find, you can also find the two maximum elements. Basically this is a for loop which is giving you some of the numbers, like z will be obviously different for every children. You have to select two of the longest length children. So like for this node, this children also return length something like 5, this is also return length something like 5. So it's your duty to calculate two of the biggest length. For example, over here every children has just two, every node has just two children, so that's why you are just getting two. But in case of these three, everyone is giving 0 0 0, and that's what you are taking. Okay, so yeah, that also doesn't make any sense. But let's say if three of them, two of them, or let's say three of them are giving, there are multiple children, it's possible. Let's say they have five children, and four children are having height is equal to 1 2 3 4, and fifth children is having height, let's say, yeah, every children is having 1 2 3 4 5. These are the five children and having 1 2 3 4 5 height. I will take 4 and 5 as my maximum and second maximum, right? Respectively. And that's about it, right? Now, after this, what you have to return to the parent? You have to return to the parent the maximum which you got, right? Z x. Now, there is a good thing about this, that you have to z plus plus. Why z plus plus? Because it is giving me, maximum value below it. Maximum value below it. So, this node is giving me what? This node, focus on this node for a part. This node is giving me maximum length, or you can say, yeah, maximum length below it. So maximum length below it is 1 2 3 4, something like that. 4 only. You have to increment plus 1 for, for this, for the length which is coming due to this addition into the new vertex, which is sv. This is currently, this is my I, and this is my starting vertex. And I is giving me something like 4, because there are 4 dots, you can see something like 4. And I to sv will give me, plus 1. So I have to do plus 1 for that matter. And this plus 1 is obviously necessary for everyone, just you do plus 1. But if it's not equal, then you cannot do plus 1. Not equal in terms of character. Now I should come on the my character part, that there is one condition in this question, which is not there in diameter and longest path problem, that your character should be equal. So now how to take that? Okay, you can pass your string. I'll pass it somehow. So s of I is not equal to s of let's say starting vertex, then you just need to continue. Don't need to focus on this, because the two characters are not same. Two characters are same. If these are equal to like a, you cannot proceed with this a length of a. You cannot say, okay, let me just increment this. What is coming from the, this is also giving me, let's say, you cannot say that 0 is having, length 2 from its left part. No, it's not having even a length 0, because it's just invalid on its left part, because a is there, right? So that's why you cannot go into this and say, okay, can it be a maximum or second maximum? No, it cannot be anything. So you just need to continue. It's having the length equal to 0 0. Okay. From Yeah, that's about it. And then you will say, okay, let's check my right part. So right part will give you length equal to 2. So your x is equal to 2, y is still 0, right? And then you have to return x to the parent, but no need for that. But now the basic thing, mx is equal to the maximum answer which you are calculating. So this is also a kind of a question when you return something, and update something else which is you are going to return anyway, like max will get updated to x plus y plus 1. Why x plus y plus 1? Because this current node is adding one candidate, like this sv. If this was sv, right? Currently I'm just processing this as sv. Okay, currently I'm processing this as sv. And this is how it's processing now. Why not moving downwards? So currently I'm processing this as my current node. So I started from this part and then got to this, now got to this, got to this. They have returned something values for this. Now I'm currently standing in this node. Before returning its value to the parent, I'm checking is there any candidate coming from that. There can be a possibility of candidate coming from it. Like if I take two maximum, like in this case 5, this is giving me 5, this is also giving me 5. So 5 plus 5 is equal to 10, but the value for this would be 11. Why? Because 1 and then 2 and then 3 and then 4 and then 5 up till this point, then 6 and then 7, then 8, then 9 and then 10. Okay, why is this? So 1 2 3 4. Okay, so length, it is giving me 4 length from here, and this is giving me, how much length he is giving me. He's also giving me, let's say, yeah, x plus y plus 1 is the number of nodes. Edges that they are giving me is 5 from this side, 5 from this side. I want number of nodes or I want number of edges? I want number of nodes. That is also the thing. That's why I'm doing plus one. In this case, number of edges is just two, but the answer is three because 0, 1, 3 are the three nodes. So yeah, the answer, it is giving me 5 from this side, 5 length from this side. So d is equal to 10. Yeah, that's your diameter. Plus one for this a number of nodes. Let's count the number of nodes. This is also a node and this is also a node, right? And SV is itself a node. So 1, 2, 3, 4, 5 nodes from this part, 5 nodes from this part, and SV is itself a node. So sixth node from SV. So that's why the answer, this is not, D is just 10 and number of nodes is equal to 7. Sorry, not 11. So that's about it. So two of the maximum answer, X and Y, addition of them will give me, a possibility for a diameter. It can be possible diameter. So that's why we have to just update our max is equal to max of this is this plus 1 for, because number of nodes is equal to plus 1 of that. And that's all about it. That's all. And mx equal to 0 or vector of graph, let me create it global because I'm using it directly, or you can just pass it as well, there is nothing issue about that. G dot resize n, and I am passing this s. Okay, that I need to pass at least something, I should pass, right? String s, otherwise you can also make it global, but it's not a big deal, so you can do it like this. And you have to return your max to the diameter, but with a condition that adjacent values has to be equal. If they are not equal, you will not consider that. And phew, resize n is not declared. Okay, so let's say n is equal to p dot size, and p is also not declared. P is parent. Anything else that we need to consider? Let's try to sum this up. So this was a basic and pretty basic problem if you know about diameter stuff. And if you don't know about diameter stuff, you should look into that first because that's something like standard. Why it's giving TLE? Okay. Hmm? And I comma S, continue. So let's try with the global string. Or maybe I am getting the thing like it's giving me TLE for this. I don't know. Let's try to see which test case it is. It is the last one or is it the second last one? Think not over here, but you can see it over there. I think, yeah, from this TL, if you click on this, you will see which test case it was. I'm not sure why this is going to be test case because previously I used string as a global thing, so there is also no difference about it. And I'm getting a feeling for this. Let's try to do a submit again. Yeah, now it fast with a pretty good efficiency. Yeah, that's about it. Yeah, this is sometimes okay. This is obviously a big thing. This is not a small thing, that passing by reference and passing by value, because every time I'm not creating a string again, right? I just need to pass it by reference. So that's also obviously very important because there are multiple calls. So yeah, you should pass it by reference, and that's all about it. Okay, guys, bye. So yeah, that was a pretty decent standard problem with the one condition that adjacent elements whenever are same characters, you need to continue. Don't need to see this path, because now this path below here is invalid for you. Whatever the calculation you needed from that path, you have done when you just called on this DFS, and this DFS, during this DFS, you got two of the maximum neighbors down there, and just to store the possibility for maximum, if it can update your maximum. But it cannot carry forward. It can give you a kind of a maximum if it just bend over. So this SV can give you a maximum if it can just bend over. Let's say this bend over is like 5 plus 5 plus 1, which is 11. But if this is, let's say, parent of SV, and this characters doesn't match, let's say this is having a character A, something like that, okay, and this SV is having a character B, which obviously doesn't match, and you will say, okay, just take the bend over part, you cannot take the carry forward part, because these two characters are not equal. So A will see, okay, I'm getting 0 from the SV side, not even 5 4 anything, you are getting 0. Even if they have 5 as a maximum length, you will get 0. But if they are matching, then only you will take 5, and then you will do +1 for that as well, right? So that's how you are doing +1 for this, and then you are incrementing it to be a maximum or second maximum. That's about it. And also taking out the bend over part for this one. Key, this is the left part answer. What is the right part answer? Let's take that. Okay, not right part, but this is the maximum or second maximum, or what is the, basically after all the calculation, what are the two maximums, and take some of that to be a diameter possibility. Okay guys, that's about it. Bye.